Hi everyone, welcome to my channel. So I hope you are fully charged up for another interesting session on laws of motion. In the previous session we have discussed till the topic of pulley mass system. Okay, and so today we will continue from that. And first we will discuss about spring balance. Okay, so we will discuss the concept by solving some questions. Okay, now spring balance, like see this is spring balance. So this is attached to some rigid support, and here you will have a spring, and there is a scale, graduated scale. Okay, and this is attached to some, suppose here you can attach a load, suppose this is M. So this is mg is the force in the downward direction, that is because of this mass. So there will be elongation in the spring, so spring force is kx. So under equilibrium, this mg is equal to kx. Okay, and there will be graduation in the scale, or the scale will be calibrated, and from that we can say that, okay, corresponding to this m, suppose this is m kg, mass is some m kg. Okay, so the weight will be m kg weight. Okay, where we know that 1 kg weight is equal to 9.8 Newton. Means you can write like weight as W is equal to M into G. Okay, or you can write it in terms of kg weight. Correct? Okay, but that is a different thing. But main concept is like, this is how a spring balance records the weight. Okay, physical balance, it measures the mass, and a spring balance, it measures the weight. Okay, now what is the concept we are trying to learn in laws of motion? Like corresponding to spring balance, this type of questions are asked. Like suppose you have two spring balances, two identical spring balances, okay, attached to a rigid support, and this is the bottom hook, and through this hook a load is attached. Now this is a single load of say mass 10 kg. Okay, now these spring balances are said to be in parallel. Okay, this is called parallel combination of spring balance. Now when spring balances are connected in parallel, this load is equally divided. This load is equally divided. It is like, suppose you are holding, suppose this is 10 kg weight, and if I am holding this with single hand, so this hand is supporting a 10 kg weight. Okay, now if I use both hands, so now this load is distributed in the two hands. So similarly here, this load will be distributed. So this spring balance will record 5 kg weight, and this will also record 5 kg weight. Okay, this is the thing. If it is in parallel, the load will be equally distributed. Okay, now suppose you have, this is one spring balance, this is another spring balance, again they are identical, and now this is, say again, this 10 kg load. Okay, this is 10 kg load. Now in this case, the two spring balances, they are in series. This is series. Okay, now if spring balances are in series, they will record the same reading. That means this will record, see this 10 kg is pulling this, okay, and this is pulling this. So this is acted upon by this 10 kg load, this is also acted upon by this 10 kg load, provided we are assuming that this does not have much mass. Okay, so this will record 10 kg weight, this will also record 10 kg weight. Okay, so in series they will measure the same weight, and in parallel it will be divided. It will be equally divided. Like suppose instead of 2, suppose you had 5. Okay, 5 spring balance, 1, 2, 3, 4, 5. Then again this 10 kg will be distributed among all the 5 spring balances, and now each spring balance will show a weight of 2 kg weight. Okay, so this is with regard to spring balance. Okay, this is one concept. I'm also going to discuss few more concepts. Okay, suppose you have this is a horizontal table, and this is a spring balance. Okay, this is the scale. Now from both sides, suppose I am attaching a weight load of 10 kg. This side also, this pulley, so this is again 10 kg. Okay, so this side you are pulling 10 kg, this side also you are pulling 10 kg. Okay, now what will be the weight shown by this spring balance? The answer is not 20 kg in this case, it will be 10 kg or 10 kg weight. This will show a 10 kg weight only. Why? Because see, in this case, one of the two loads will act as a support. It is like, suppose you have this is the spring balance. So this is the support, and from this end we are attaching a load of 10 kg. See, the spring balance in this case also, it is being pulled by two forces. This 10 kg load, this support is also pulling it. It is pulling it from the upward direction. But this is acting as a support. So that is why if this is 10 kg, this is showing a reading of 10 kg weight. Correct? So here also, out of these two loads, one will act as a support, any one, and the reading will be 10 kg weight. Okay. Another example, like suppose you have this is 10 kg, this is 10 kg, and here you have a spring balance. This is the pulley. Okay, this string is going like this. So this is the spring balance. Okay, and you are asked to find the reading from this spring balance, means what is the weight. Okay, so in this case, this is 10 kg, this is 10 kg. Okay, so that means, see, suppose this is mg, this is mg, so this is T, this is T. Now if this is T, this is T, here the tension will be twice T. Okay, now system is in equilibrium, so T is equal to mg. So that means twice T is equal to how much? Twice mg. Correct? What is mg? This is 10 kg weight. So this mg is 10 kg weight. So this 2 mg means 20 kg weight. So this will record a rating of 20 kg weight. Okay, I hope these concepts are clear. Okay, so let's proceed. Let's see another example. Now suppose this is a rigid support, this is a spring, this is a load 1 kg, another spring, this is 2 kg. Okay, both the springs are identical. Suppose this is K is equal to 100 Newton per meter, this is also K is equal to 100 Newton per meter. Okay, we have to find the elongation in the two springs. Okay, extension or elongation in two springs. This we have to find. Okay, now whenever such situations are given, we have to draw a free body diagram. Free body diagram means mark all the forces. Okay, so this is 2 kg, so this is 2g. Okay, so suppose here the spring force is kx1, so here also spring force will be kx1, where x1 is the elongation. For this 1 kg, again 1g force, mg force will act in the downward direction. For this spring, kx2, where x2 is the elongation in this spring. Okay, so for this block, if we see this kx1 is equal to 2g. 2g is the downward force, kx1 is the upward force. It is in equilibrium obviously after undergoing elongation. Correct? Achha. So x1 is equal to 2 into 10 divided by 100. So that's equal to 0.2 meter. So in this spring, the elongation will be 0.2 meter. How about this? For this 1 kg, kx1, it is acting in the downward direction. 1g is also acting in the downward direction. So it is equal to kx2. Okay, how much is x1? x1 is 0.2. So k is 100. So that is 20 plus 1g, that is 10, is equal to 100 into x2. So this is 30. That means x2 is equal to 0.3 meter. So elongation on this spring will be 0.3 meter. Elongation on this spring will be 0.2 meter. Okay. So I hope this is clear to you. Now moving to the topic of friction. So friction is, see, basically suppose this is a horizontal surface and this is a block of some mass m kept in contact with the horizontal surface, and I am trying to move this block in this direction by applying some external force F. Okay. Now obviously when this force is applied, there will be some relative motion between this block and this horizontal surface. And because of this relative motion, a frictional force will be developed on the lower surface of this block in the backward direction. Okay. So basically this friction, it is a contact force. It is a type of contact force that is developed parallel to the surface of contact. Okay, it is always developed parallel to surface of contact. Parallel to surface of contact. Okay, and what it opposes? It don't oppose the motion. Okay, it opposes the relative motion. Okay, friction, it opposes the relative motion. Relative motion. Okay, like for example, in this case, see this block. If I am drawing this block separately, so this block is acted upon by force F in the forward direction. Okay, so that means this block, relative to the horizontal surface, it is trying to move in the forward direction. So that means on the lower surface, the frictional force, lower surface of this block, the friction force will act in the backward direction. Whereas if we consider this horizontal surface, for this horizontal surface, the frictional force, it is acting in the forward direction. Because see, friction force is a contact force, and we have discussed in the previous class, contact force are, they always exist in pairs. Okay, if one force is the action, the other force is the reaction. Okay, so this is about friction. Friction is a type of contact force, it opposes the relative motion. Now another important thing is, see this frictional force, it is independent of area of contact. Independent of area of contact. Okay, how large is the area? It does not depend on it. It depends on nature of area of contact. It depends on nature of area. Whether the surface is rough or smooth, on all those things it will depend. Okay. Now suppose this is a horizontal surface and this is the block and it is acted upon by force F. Okay. Now initially this force is 0. Suppose initially I am not applying any force. This block is just placed. Okay. And when no force, horizontal force is applied, so there is no tendency for this block to move. So there is no friction also. Friction will only come when there is a relative motion or when the block is just trying to move, even when it is rest, but it is trying to move. Like for example, I am applying a force, now I am applying a force F, but that force is not sufficient for this block to move. But now friction has come. Okay, now friction is acting in this direction. So this is the friction force. Okay, now suppose if I draw a graph between frictional force and applied force. So initially, see, there is no applied force, so friction force is also 0. Now, as the applied force is increased, the frictional force also increases linearly, and it is in rest. Okay, and I am gradually increasing this applied force. Okay, now at some particular value of the applied force, this friction force will become maximum. And now if I again increase the applied force, the block will begin to move, so friction force will gradually decrease. Okay, so this is the nature of the graph. Now friction, see in this part, the motion of the block has started. So here the friction is called kinetic friction. Kinetic friction. And this part, the block was stationary, so here the friction is called static friction. Static friction. Okay. See, under static condition, applied force is equal to the static friction. Okay. Under static condition, static means stationary condition. Stationary state. If I represent static friction as Fs, it is equal to the applied force, F applied. Okay. Now, see this friction. Suppose in this case, this is mg, and this is normal reaction. Now, this friction force is proportional to the normal reaction. So, F friction force is equal to mu times N. In this case, N is equal to mg, and it is not necessary that N is always equal to mg. Okay. So, we will see such situations also. So, F is equal to mu times N. This mu is called coefficient of friction. This mu is coefficient of friction. So, if it is in static condition, the coefficient of friction is mu s. If it is in kinetic condition, that is in moving, then coefficient of friction is mu k. Okay. Now, for same body, for same suppose block and the surface, this mu s will be greater than mu k. Mu s will be greater than mu k. Coefficient of static friction will be greater than coefficient of kinetic friction. Okay. So this is about the concept of static friction and kinetic friction. Now let us apply this concept to solve a question. Okay, very interesting question. So we have a block, okay, of mass 1 kg, mass 1 kg, and it is placed on a horizontal surface, rough surface. Okay, there is friction, and mu s is equal to 0.2. Coefficient of static friction is 0.2. Mu k, coefficient of kinetic friction is 0.15. Mu s greater than mu k. Okay. Applied force, we are applying forces of 3 values. Okay. One, we are applying force of 1 Newton, then 1.96 Newton, and then 2.5 Newton. Okay. And we are asked to find the value of the frictional force. Okay. So this is the applied force. Applied force is it is applied horizontally. Okay. So this is mg. This is normal reaction. So here I am going to take G is equal to 9.8 meter per second square net, and not 10 meter per second square, because here 1.96 Newton value force is given, which is a multiple of 9.8. Okay. So mg, this will become 9.8 Newton. Okay, and this is the frictional force. Since the applied force is in this direction, frictional force will be in the opposite direction. Okay. Now, when applied force is equal to 1 Newton, when applied force is equal to 1 Newton, let's see what is the value of the frictional force. Okay. I don't know whether the block is going to move or not. Okay. Now, let's see what is the static friction. Fs is equal to mu s times normal reaction. Here, normal reaction is how much? Normal reaction will be equal to mg, because there is no motion in this direction. So, n is equal to 9.8 Newton. Okay. So this is mu s is equal to how much? Mu s is 0.2. So 0.2 into 9.8. Okay, 0.2 into 9.8. This is equal to how much? This is equal to 1.96 Newton. Correct? Now, as you can see, that means in this direction there is a force of 1.96 Newton. Applied force is 1 Newton. Okay. That does not mean it will move in this direction. It only means that applied force is not sufficient to move this block. And friction, remember, this friction is a self-adjusting force. Okay. So under static condition, static friction value is always equal to applied force. So that means here, since this force, static friction, is less than the applied force, so here this implies static friction value will be equal to 1 Newton. I hope you are able to understand. See, this applied force is 1 Newton. Okay. Static friction value, calculated value is 1.96 Newton. That means in this direction the force is 1.96 Newton. Like, suppose if I am keeping this duster over this notebook, and if the applied force is less than the friction force, it does not mean this duster will move in the backward direction. It is impossible, isn't it? So it only means that this block is in static condition. So under static condition, the static friction will be equal to the applied force. Obviously, because since the block is not moving, the force in the forward direction is equal to force in the backward direction. So Fs equal to 1 Newton. Okay. Now similarly, when we apply force of 1.96 Newton, again static friction value will be 1.96 Newton, because it is still not able to move. Okay. But so for second case also friction force is 1.96. For this 1.96 Newton case, again the friction force will be 1.96 Newton. When the applied force is 1 Newton, friction force is 1 Newton. Third case, when applied force is 2.5 Newton. As you can see, static friction value is 1.96 Newton. Applied force is 2.5 Newton. So that means now the block will not remain at rest. It will start moving. Now once it starts moving, kinetic friction comes into picture. Isn't it? So here friction force, we need to calculate kinetic friction, Fk. So that will be equal to how much? Mu k times coefficient of kinetic friction times normal reaction. So this is 0.15 times normal reaction. Normal reaction is 9.8. Okay, so this much. Okay, so I hope this concept is clear, when to apply the concept of static friction, when to apply the concept of kinetic friction. Okay, so let's proceed. Another question is based on this chain. Okay, this is quite common in any kind of entrances. Suppose this is a horizontal table. Okay, this table, horizontal part of the table, this is the leg of the table, this is the chain. So this is chain of length, total length of the chain is L. Okay, mass of the chain is M. So we have to find how much part can hang over the edge. This part is hanging over the edge, so that this entire thing remains on the table. Means this part remains on the table. Suppose if I increase this length, then this part will fall down. Okay, but for this, suppose this length is hanging. Suppose this is Y. So obviously this is L minus Y. Total length is L. So when this length is hanging, suppose till this length, this is the maximum length that can hang over the edge, so that this part remains on the table. It does not slips. Friction is able to prevent this part to come down. Okay, because who is pulling this part in the downward direction? This hanging part. Okay, so what if M is the mass, L is the length? Mass per unit length will be how much? M by L. This is mass per unit length. Mass of unit length. Correct? So that means mass of this length will be how much? M by L into Y. Okay, so what will be the weight of this part? G. So this weight is acting in the downward direction. Okay, why the chain is not coming down? Because of the friction that is acting in this part. It is acting in this direction, friction force. Correct? Now suppose, let's say mu is the coefficient of friction, that is also given. Okay, so for this part, what will be the normal reaction? Normal reaction, for the normal reaction I need to find the weight of this part. Okay, for weight I need to find the mass. What is the length of this part? It is L minus Y. What is the unit length mass? M by L. So for this part, mass will be M by L into M minus Y. This is the mass into G. This is the weight, and this is equal to the normal reaction. If I multiply this with mu, that is the friction force. Okay, so this friction force is acting in this direction. Weight of this hanging part is acting in the downward direction. If it is not coming down, that means these two forces are equal. So this force and this force I need to equate. So this is equal to M by L Y into G. Correct? So this M by L gets cancelled, G and G gets cancelled. So this is mu L minus mu Y is equal to Y. So Y is equal to mu L divided by 1 plus mu. So this is the maximum length of the chain that can hang over the edge, so that this part remains on the table. Okay, so I hope this solution is clear to you. Achha, next let us see this concept of push and pull. See, suppose this is a block of mass M, and I am pulling this block by applying force F in this direction. This is theta, so this will be F cos theta, this will be F sin theta. This is mg, this is the normal reaction, this is the frictional force. Okay, so here in the vertical direction there is no motion, so total upward force equal to total downward force. So n plus F sin theta is equal to mg. So m is equal to mg minus f sin theta. Okay, this is when we are pulling. Now for pushing, what will happen? Same block. Suppose I am applying force F in this direction. Okay, and suppose this horizontal, this angle is theta. With the horizontal direction of force is making an angle theta. Okay, so that means if I extend this, so this is theta, so this is F, so this will be F cos theta, and this will be F sin theta. This is mg, this is normal reaction, this is the frictional force. Correct? So here again, see here also F cos theta is responsible for the motion of the block. Here also F cos theta is responsible for the motion of the block. But see here again, no motion is taking place along the vertical direction. So total upward force is again equal to total downward force. So N is equal to F sin theta plus mg. So as you can see here N equal to mg minus F sin theta. Here N equal to mg plus F sin theta. So obviously this normal reaction is greater than this normal reaction. So when you are pushing, the value of normal reaction increases. Now if the value of normal reaction increases, frictional force will also increase, because frictional force it is proportional to normal reaction. Correct? So here the value of friction will be more. Here we have more opposition to the motion. Okay, so it is for this reason pulling is easier than pushing. Okay, so I hope this concept is clear. Okay, now next we will calculate for pulling what is the minimum value of this force. Okay, minimum force for pulling. So minimum force to pull the block. What is the minimum value of this force? Okay, so here see, suppose this is just able to move, this force is just able to move the block. So in that case I can write F cos theta is equal to mu n. F cos theta is equal to frictional force. Okay, and what is the value of N? N is equal to mg minus F sin theta. So this is F cos theta is equal to mu times mg minus F sin theta. Correct? So this is F cos theta is equal to mu mg minus mu f sin theta. So I can write F is equal to mu mg divided by cos theta plus mu sin theta. Okay, so as you can see, the value of this F changes with theta. Mu is constant. Mu is constant for a given pair of this object and the surface. What we can change is theta. Mass is again constant because we have the fixed block. Okay, so this force changes with theta. Okay, so if force changes with theta, for minimum value of this force, what will be df by d theta? For minimum theta, for minimum f, sorry, for f is equal to f minimum, df by d theta, it should be equal to 0. At maxima and minima, the slope becomes 0. Correct? So let us find the value of this df by d theta. So this is minus mu mg. This is cos theta becomes minus sin theta plus mu cos theta is equal to 0. Okay, so I am differentiating this. Denominator I have not written because it will vanish. Okay, so simplifying this, you get mu is equal to tan theta. So for mu is equal to tan theta, force will be minimum. Correct? So let us substitute that value over here. So if I divide this numerator and denominator by cos theta, what do I get? F is equal to mu mg sec theta divided by 1 plus mu tan theta. Correct? Now for mu is equal to tan theta, force is minimum. So if I write F minimum is equal to mu mg sec theta divided by 1 plus mu square, tan theta can be replaced by mu. Achha. Now I can rearrange this as like 1 plus mu square can be replaced by tan square theta. Okay, so 1 plus tan square theta is sec square theta. So this is sec square theta. So this is mu mg by sec theta. Now sec theta can again be replaced in terms of tan theta. So this is mu mg divided by square root of 1 plus mu square. So this is the value of the minimum force that can be applied to move this block. Okay, mu mg divided by square root of 1 plus mu square. This result is important. Okay. Now suppose you have this horizontal surface. This is a block. This is the applied force. This is the normal reaction. This is the frictional force. Okay. Now this is the frictional force. This is the normal reaction. So resultant of these two forces. Suppose this is the resultant. Okay. So angle between this resultant is the resultant of friction force and normal reaction. So angle between this resultant and the normal reaction, this angle theta, this is called angle of friction. This theta is the angle of friction. Okay. Now as you can see here, tan theta, it will be equal to perpendicular by base, so that is f by n, so that is equal to coefficient of friction. So tangent of angle of friction is equal to coefficient of friction. Okay. Now another term is angle of repose. Angle of repose. Like it is like, suppose this is a horizontal plane and this is a block placed on the plane. Now if I increase the inclination, see it is stationary, and at some particular angle this block will come down. So the maximum angle of inclination, this maximum angle of inclination for which this block remains stationary, that angle of inclination is called angle of repose. Okay. So suppose this is alpha. Now till this angle, this block is stationary. If angle is increased beyond this limit, the block will come down. Okay. So that angle is called angle of repose. So for this block of mass m, this is mg. This angle is alpha. So this is mg cos alpha. This is the normal reaction. Okay. So this will be mg sin alpha. This is the frictional force. Okay. Now if the block is not coming down, now this friction force is F is equal to mu times normal reaction. Normal reaction is mg cos alpha. So mu mg cos alpha. Now if the block is not coming down, that means friction force is equal to mg sin alpha. So mg sin alpha is equal to mu mg cos alpha. So this mg gets cancelled. Cos alpha, bring it here, so it becomes tan alpha. So mu is equal to tan alpha. So here we are getting mu equal to tan theta. So that is coefficient of friction is equal to tangent of angle of friction. Here we are getting coefficient of friction is equal to tangent of angle of repose. So that means angle of friction and angle of repose they are not equal. They are numerically equal. Numerical values are same. Okay. Now suppose you have a plane, inclined plane, whose inclination is just greater than alpha. So that means the block will come down. So what will be the acceleration of the block? Acceleration of the block, suppose the inclination is theta and this theta is greater than alpha. Suppose this theta is the angle of inclination of this inclined plane and this theta is greater than alpha. So the block is coming down. So in that case, acceleration of the block will be equal to how much? See, downward force is mg sin theta and upward force is this friction force mu mg minus mu mg cos theta. This is the force, net force divided by mass, that is the acceleration. So this mm cancels. So A is equal to g sin theta minus mu g cos theta. So this will be the acceleration of the block down the inclined plane. Okay. Now again, suppose for the same case, theta greater than alpha. Now for theta greater than alpha, we are trying to find the minimum value of force so that the block moves in the upward direction. So that minimum force will be how much? See, if you are moving the block in the upward direction, this friction force will act in the downward direction. So in this case, friction force and this mg sin theta, they will act in the downward direction and applied force will act in the upward direction. If the force is just able to move, that means this force will be equal to sum of this force and the friction force. So F is equal to how much? It will be equal to mg cos mg sin theta, that is this force plus the frictional force plus mu mg cos theta. Okay, so this force, which is the minimum force, that will be able to move the block in the upward direction. Okay, so now let us solve one question from JEE Main 2019. Okay, so you have one inclined plane of inclination 30 degree. This is a block of mass 10 kg. Okay, and this is a force acting. This force is of 3 Newton. It is acting in the downward direction. Okay, coefficient of static friction mu s is given to be 0.6. Okay, and it is asked what should be the minimum value of P. P is applied in this direction. What should be the minimum value of P such that block does not move downward? Okay, this inclined plane, rough plane, static friction, coefficient of static friction is 0.6. This is 30 degree, mass is 10 kg. In this direction, the force is 3 Newton. This force is acting. You have to find the value of this force P so that the block does not move in the downward direction. Okay, block does not move in the downward direction. It should not move in the downward direction. That is also given. Okay, so you have to find the value of P. Okay, value of G is 10 meter per second square. Okay, you can pause the video and try this question, and then you can verify with my solution. Okay, so let me proceed with the solution. So since the block should not move in the downward direction, so that means the friction force is acting in the upward direction. This is the most important thing. Okay, because you are trying to avoid the motion in the downward direction. So that means the friction force must act in the backward direction, because I told you friction always opposes the relative motion. Okay, Acha. Now since I know this means the direction, so this is 10g, this is 30 degree, so this is 10g cos 30 degree, and in the downward direction it will be 10g sin 30 degree. Okay, since it is not moving in the downward direction, that means total upward force equal to total downward force. So downward force is this 3 Newton plus 10g sin 30 degree is equal to P plus the friction force. And how much is friction force? Mu s times normal reaction, but normal reaction will be equal to 10g sin cos 30 degree, 10g cos 30 degree. This is the condition for block to remain stationary. So that means for block not to move. Okay, so it should not move downward. So that is why I have marked friction in the upward direction. So this is 10g sin 30 degree. Sin 30 is half, so this becomes 5. Okay, cos 30 is root 3 by 2. So this is root 3. This becomes 5. Okay, so this is 3 plus this is 5g 50 is equal to P. Mu s is 0.6. 0.6 into 5 into 10 root 3. Okay, so if you simplify this, calculation can be done by you. So this value comes to be around 32 Newton. Okay, 32 Newton. So this is how you have to solve. Say here the important concept is direction of this friction. So another interesting question from concept of physics friction chapter. This is question number 23. You have this horizontal surface, okay, and then you have this block of mass 7 kg over this another block of mass 3 kg, another block of mass 2 kg. Okay, and friction between this 2 kg and 3 kg, it is mu1, it is equal to 0.2. Friction between this 3 kg block and 7 kg block, it is mu2, it is equal to 0.3. And friction between the 7 kg and this horizontal surface, mu3, it is equal to 0. Okay, and a horizontal force of 10 Newton is applied. Horizontal force of 10 Newton is applied, first to 2 kg, then to 3 kg, then to 7 kg, and we have to find acceleration of each block. Okay, so first case, suppose this force of 10 Newton is applied to 2 kg block. Okay, now if this force is applied to this 2 kg block, then what happens? See, this 2 kg block, this is 10 Newton. So between this 2 kg and 3 kg, the friction coefficient is 0.2. So this friction will act in the backward direction. So this is F is equal to 0.2 times normal reaction. So this is 2g means 20 Newton. This is the normal reaction. So normal reaction is 20 Newton. So this is 0.2 times 20. So that is equal to 4 Newton. Okay. So that means this 2 kg block is acted upon by a friction force of 4 Newton. Applied force is 10 Newton. So obviously this block is going to move. So if this block is going to move, what will be the acceleration of this block? A will be equal to, this force is 10 Newton, forward direction 10 Newton, backward direction 4 Newton, 4 divided by mass, net force divided by mass. So this is 3 meter per second square. So that will be the acceleration of this 2 kg block. Okay, now let's see what happens to this 3 kg and 7 kg. Now, see, 2 kg block, for this 2 kg block, friction force is acting in the backward direction. 2 kg and 3 kg, they are in contact. Friction force is a type of contact force. That means below 2 kg block, friction force is acting in the backward direction. So above 3 kg block, friction force will act in which direction? It will act in the forward direction. So for this 3 kg block, this friction force will act in the forward direction. How much is the friction force? This is 4 Newton. So this is 4 Newton. So this 4 Newton force will act as a driving force for this 3 kg block. Okay, but let's see whether this 3 kg block is going to move or not. Now see, above 3 kg you have this 2 kg block. So that force is also acting in the downward direction. So this is 5g. 2 kg, 3 kg and 2 kg, 5g. So that is equal to 15 Newton. So this friction force below 3 kg block is 0.3. So 0.3 into 50. So that is equal to 15 Newton. So that means this 3 kg block, it is acted upon by a friction force of 15 Newton. Driving force is 4 Newton. So that means this 4 Newton force is not sufficient for this block to move. Means there can't be any relative motion between 3 kg and 7 kg. Okay, there can't be any motion between 3 kg and 7 kg. Relative motion is not possible, but below 7 kg there is no friction. So what will happen? This 3 kg block, and 7 kg block, they will move as a single unit. So what will happen? This is 3 kg and 7 kg, single unit. Here the force is this 4 Newton force, it is acting in the forward direction. So this 4 Newton. So here there is no friction, so they will move together. So what is the combined mass? 10 kg. So acceleration will be how much? 0.4 meter per second square. So that means this 3 kg block and 7 kg block, they will move together with the acceleration of 0.4 meter per second square. And this 2 kg block will move with the acceleration of 3 meter per second square. This is the case when this applied force, 10 Newton force is acting on 2 kg. Okay. Now, similarly, you should try that if this force is acting on 3 kg, what will happen? If this force is acting on this 7 kg, then what will happen? Okay. So for that, this is your task. You should do it. Okay. You can verify the answer from the book, Concept of Physics. This is quite a popular question. This is question number 23. Okay. So these were some of the important concepts based questions from the topic of friction. Okay. So this is all about laws of motion. Not all about actually, but these were some of the important concepts, as it is fairly not possible to discuss each and every concept. But I have discussed all the important concepts at least. Okay. So based on this discussion, again today also I will share one worksheet and you should try those questions and then give a feedback. Okay. So with this I end this video. Hope this video is beneficial to you. My best wishes.